Awesome. Well, welcome to the second episode of Absolutely Zero Knowledge. And I'm really excited for this guest. So I'm welcomed by Jason from Zama. So I think this is going to be a nice angle because Jason and Zama, they're working, they're touching upon zero knowledge a little bit, but they're also working more deeply on FHE, fully homomorphic encryption, which, to be totally honest, put my hands up, I know even less about that than I do about zero knowledge, which is why I'm excited to chat to Jason, learn a little bit more, hear about some comparisons, hear what he's working on at Zama, and just, once again, see where the conversation takes us. So, that's where we see the episode going. But Jason, do you want to, introduce yourself a little bit quickly?
Absolutely. Thanks for receiving me. My name is Jason. I'm working for Zama as a blockchain ecosystem lead. So Zama is a cryptography company developing a new primitive, a cryptographic primitive, same as ZK. Zero knowledge is a cryptographic primitive. FHE is another one. I'll explain the difference. And so Zama is a French company based in Paris. I'm also based in Paris. And we are accelerating FHE. So FHE means fully homomorphic encryption. It's a complex name from something really simple. FHE is the ability to compute unencrypted data. Say I take some personal data, I want to encrypt them using my private key. Then I send it to a server, a third party, a blockchain, anybody else, a cloud. They can do the computation on the data without even seeing them. Usually on a normal web infrastructure, the server has to decrypt it, do the computation, re-encrypt it, and send it back. Now in this case, it doesn't even see the plain text information. So that's some kind of magical cryptographic black box. And historically, it's been quite slow. And the mission of Zama is to accelerate this kind of process. So that's the basic idea of what we do. We develop everything we do is fully open source. So we develop open source technology, and this can be used in health, industry, with banking, in financial services. And I am specifically working on the blockchain industry. So we have a blockchain version of our product. It's called the cfhEVM. And my goal is to find the best use case of the cfhEVM for developers and within the blockchain industry.
Mm-hmm.
That's it.
Awesome. And I know loads of those things you've mentioned there, we're going to get into plenty more detail about. So, I won't ask too many questions just now because, we'll lead on to that. But that's an awesome overview of a little bit about Jason. A very quick one as well. How did you get into the cryptography space to start with then? What was your journey like into your current role?
Yeah. So I used to work for a web agency based in Paris, and I discovered Web3, blockchain, crypto, Bitcoin progressively between 2017 and 2020 with the beginning of the DeFi summer. I was just privately following this on Twitter. And then I started launching a business unit in the web agency I was working for about blockchain. So that's how I first got, because we had new business lines around blockchains. And then I quit my job and tried to launch a decentralized application on top of Ethereum layer 2 called Starknet with a co-founder. The project didn't work out. We decided not to launch the project, but I first learned about ZK cryptography, SNARK, Starks, and this kind of thing. And then I had a discussion with Round, the CEO of Zama, who told me about FHE and what they were building. And so I started working for Zama 9 months ago.
Awesome. And was it, I mean, obviously the blockchain space is pretty broad. Is cryptography specifically something that interested you? And because I guess what I've learned on the ZK side is that it's a space that's growing massively. I guess FHE probably is the same. Once again, we'll touch upon it. But cryptography is something in particular that was of interest, or did you fall into it a little bit?
To be honest, I wasn't at all interested in cryptography before 2 years ago. I was interested in blockchain. I was interested in DeFi because I understood the need for all the benefits of this world, decentralization, censorship resistance, all those properties I understood, but cryptography was not really interested to me. But then I soon realized that it was absolutely needed for scalability. That's what ZK has been doing to Ethereum, scaling it. And so another big problem, there is three big problems in the crypto space right now, in the blockchain space. We have to scale it, we have to make it more secure, and we have to make it more private. There is an article by Vitalik explaining the three main big challenges, that those three. And then I realized that FHP could be super helpful for the third one, privacy. And so, yeah, I went down the rabbit hole, and now I'm trying to understand how we can leverage it.
Brilliant. And I mean, you mentioned ZK. Obviously, we know all about that, and FHE. You've touched upon and given us a definition. There's almost lots of different. Is the right word protocols or primitives within cryptography? There's MPC as well.
Yeah.
Obviously, cryptography is something that's been going for years and years, almost decades and centuries in its oldest format. But what's caused it to, I guess, suddenly accelerate in the last, I don't know, 5-10 years? Is it the whole privacy and scalability aspect that you touched upon there, and the whole, elements of data security that's suddenly driven this as data's become more accessible? Or what suddenly accelerated the growth of cryptography, do you think?
I'm not a specialist about the history of cryptography, but my guess is blockchain and Bitcoin brought some money in the space. Before that, it was mostly a research stuff. ZK was all DK is based on a paper from 1985. It was just a curiosity back in the time. But then some people realized it could solve some major problems from Bitcoin. And so that's how people like Elie Ben-Sasson from Starkware started. I remember a conference from him in 2013 explaining how ZK could scale Bitcoin. And then as lots of money flew into this space, the research accelerated, and ZK was solving a real big problem, scalability, and it fit perfectly with the layer 2 centric roadmap by Vitalik, and everything accelerated very quickly. And so now you have like dozens of layer 2s based on different ZK primitives, and hopefully the same will happen for FHE. So now all the major theoretical problems are solved. We just need to make it a reality or make it production ready, and that's exactly what Zama is about.
Mm-hmm. And obviously you're specifically working on the blockchain side of things, but from what you've mentioned already, and the tiny bit of research I've done, for example, the use of FHE to figure out computations on medical data, for example. So without sharing much detail around that, you can organize or sort medical data, for example. Where do you see the growth of FHE? Is it going to be across Web3 and sort of typical Web2 use cases, or where's it going to go?
So for FHE FHE today is ready for the blockchain industry. Why? Because blockchain industry is an industry ready to implement new cryptographic tools. That's not the case for other industries, and it's already used to slow transaction. We are okay with waiting a few seconds for Ethereum transaction to go through the process. And so as FHE is still quite slow, it's an industry okay for implementing it. Then after 2025, we'll have custom hardware accelerators like ASICs. And with those ASICs, FHE will be able to handle the requirements from the Web2 world, from the normal financial world, from the health world. So right now, it's not exactly ready. People have requirements that we cannot match. We can only match the requirement in the blockchain industry. So this is our go-to-market with Zama, the blockchain, in the next 2 years. But after that, we'll be able to FHE will be used in many more, and as you mentioned, health and financial services.
And more specifically on the blockchain side of things, then, what really simple question I've mentioned before. I might ask some daft questions, but what are the key use cases? Why is a a layer one, or why is a company going to use FHE or use Zama services, for example?
So today, everything you have on blockchain is transparent. So on-chain data is public by design, and there is lots of application you cannot build because of this full transparency. Okay. The problem you have is you have lots of MEV, so maximum extractable value, people who are front running you to extract some value out of your transaction. That can be a threat because people know how much money you have. Yeah. And there is just some stuff you cannot put on chain because of the transparent nature. So the FHEVM brings the ability to send encrypted transaction and data to an EVM. And with this, we have 6 major use cases, 6 major categories you can have. First is accelerating tokenization. As you know, tokenization is a strong narrative right now. You want to take the real world assets, so the assets that exist already in finance, like the US dollar, stablecoins are real world assets. You want to tokenize bonds, you want to tokenize stocks, equities, everything. There are trillions and trillions of assets that are being tokenized on blockchain because it's a better infrastructure to transfer value. And with the FHEVM, you can tokenize asset classes that require confidentiality. I'll take an example. Imagine you have some equity for your company, but for some reason, you don't want, you are not public as a company. You don't want anyone to know who, the ownership of the cap table of your company. Right now, you couldn't tokenize it on a blockchain because if the transaction would be pseudonymous and you could reconstruct, you can extract lots of data even though it's pseudonymous. Yeah. With FHE, you could have a cap table that is fully encrypted, meaning that you don't even know how many tokens each member has. So we are accelerating tokenization. That's the biggest, one of the biggest use case. Then you could do some blind auctions. So auctions are everywhere in finance. You're always auctioning stuff in markets, in bonds. And with FHE, you could have a smart contract running a blind auction, meaning imagine 3 people, they are bidding in an encrypted way, so nobody knows how much they are bidding. And then the smart contract can give the assets to the highest bidder without revealing the amount of the bid. And so that's another use case. You have games. There is lots of games you cannot play on chain today. Most of the casino games, like poker and blackjack, because they require an encrypted state. You wouldn't play poker with someone if all the states of the cards would be on chain and easily accessible. It doesn't make sense. Yeah. You cannot transact privately. So with this new primitive, we enable new form of games. So gaming, confidential voting. DAO can vote without revealing who they are voting for, which is a normal mechanism for voting. We are just bringing normality back where it wasn't here. And you can have encrypted DID, meaning that all your ID information, you can put them on chain and generate attestation, for example, saying that you are more than 18 or that you are not an American citizen. Without needing to compute everything off chain. Everything can happen on chain. So you keep the composability and the interoperability. So that's the main use cases.
Yeah, and obviously there are some slight. They are similar, obviously, in ZK and FHE. There are some slight differences. Why would someone use one and not the other, or is it because the use case in particular requires an element of FHE that wouldn't quite be suitable for using ZK technology? Or is there a reason why someone would opt to use ZK as opposed to FHE, or the other way around? Or is it just because that's just what their need is?
So first, they are mostly complementary technology. They are not like a competitor of the technology. And so ZK today, in its current form, is mostly a scalability technology. What's interesting in ZK today in blockchain is its ability to create a very succinct proof of computation that is exponentially easier to verify than to redo the whole computation. It's not the zero knowledge. It's not the privacy part of the zero knowledge technology that is mostly used for Ethereum. So I would say it's 80% used for scalability and 20% from privacy. The problem with privacy in ZK is that at least one person, the prover, the entity generating the proof, needs to seize everything. So you have at least to trust one prover. And you cannot have multi-agent use cases that, as I just described with the auction. You cannot have a smart contract running different encrypted states and computing all the results. That's not possible. So the design space of privacy application with FHE is much larger than what you can have with ZK. With ZK privacy, you can build stuff like Zcash because it's only private transfer, very simple, bilateral stuff. But you cannot build multi-agent complex privacy use cases.
Yeah, and from a, I guess from a more technical perspective, for example, the people that are working at Zama, the cryptography engineers, the cryptographers, I've slowly started to get my head around what a cryptography engineer does within the ZK space. They're working with, different proving systems. They're working on different circuit design. What are they? What is a cryptography engineer? What are the sort of intricacies of that role in the FHE space?
So FHE crypto engineering is all about acceleration.
Mm-hmm.
We have one metric, which is the amount it takes to perform a certain operation. We want more operation possible, and we want operation on larger integers. It's beyond my technical knowledge to explain you in details because I'm neither a cryptographer nor a developer, but they are like either adding new operation or making existent operation available for larger numbers in a decent amount of time. And so there is plenty of trade-off, plenty of choice on how to accelerate this.
Mm-hmm. And I might be completely wrong here. I think I'm right. So are your engineers using Rust over at Zama? Yeah, and obviously people know that my team is traditionally a Rust team, and that's how I stumbled upon the cryptography world to start with. And it obviously seems to lend itself really nicely to cryptography work because of, I guess, the memory safety, the privacy, the speed of Rust as a language.
Exactly.
Why have you opted? Is it those reasons exactly? Is there anything else in particular you want to share about why you sort of opted to use Rust at Zama, or why it lends itself so well in the FHE space too?
I'm not a specialist, but what I can tell is that people love Rust in Zama. Like it's something I discovered. I didn't use. I didn't have experience with Rust before, but from seeing engineers working with us, they just love the technology. It's like a religion, and lots of memes, lots of stuff like this. And you have also we have been if I'm not wrong, I think we have been contributing to the Rust Foundation from quite a long time. You can, I guess, you have Zama's logos on the Rust Foundation, and so just to make things in the right order, so we are building FHE. FHE is based on mathematics and papers. So we have some researcher mathematicians, and then we have Rust engineers that turns those papers, those basics mathematics, into a usable Rust library for developer. And our goal is to abstract away all the complexity of doing FHE stuff for developers. Because in the past, you had to be a developer plus a cryptographer to manipulate FHE. What we want is an easy way for developers who are not cryptographer, most of them, to be able to use our Rust product.
Yeah, no, spot on. And yeah, I think it's you're echoing there the words of probably virtually every single person who uses Rust. It's not the first time we've heard that, and it's the reason why on all the Stack Overflow surveys and bits and pieces, it's always the most loved programming language. So yeah, that's not out of the ordinary how much you love it over at Zama. And yeah, you mentioned about off camera. You mentioned about the difference between privacy and confidentiality, and how that lends itself well to what you're working. Obviously, we've touched upon privacy and why FHE lends itself well to that. But what's the difference between those two things, and how does that impact your work?
We like to make a distinction between privacy and confidentiality. So privacy is more about like personal stuff you want to hide, while confidentiality is more about business secrecy. That's normal to hide. The amount of goods you buy from a supplier is a confidential information, and like your personal data is your private information. So that's the first distinction we try to make in the privacy space. And another one is which information are you making private? So because there is a question we are asked a lot. You didn't ask it, but I will answer it. Is what's the difference between the cfhEVM and the privacy we bring to the blockchain and Tornado Cash? Mm-hmm. And let's take a normal Ethereum transaction. I'm sending you 20 tokens.
Yeah.
Okay. There is two different information you can make private. You can either hide the data, which is a 20 token. I am sending X token to you. Nobody can see it. That's what we do.
Yeah.
We hide the data of the transaction, but you can also hide the metadata of the transaction, and it's exactly what Tornado Cash is doing. You don't know who is transacting with who, but you know that it's bunch of 1 ETH or 10 ETH that are transacting through. So yeah, in some cases it's the hiding the metadata, and the other one is hiding the data. FHE is really, really good at hiding the data. So you know who is transacting with who in a FHEVM, but you don't know the amount.
Mm-hmm. Okay, cool. And you mentioned a couple of times about the FHEVM, and I know there's works in the pipeline. Maybe it's a little bit further afield to combine ZK and FHE. We've mentioned the differences between the two, and how one, as ZK is more on the scalability side, FHE more on the privacy side of things. But I guess there is a case for them to be used side by side. Do you think that's something that's going to take off? But also, I know there's certainly some things in the pipeline with Zama where you might be able to harness that.
So it's obviously something we want, because we want decentralized infrastructure. Okay, that's the blockchain. Then we want the ability to generate proof of computation, so that not everybody has to redo the computation. It's easier. That's why you have zkFHEVM. When the computation is done, you can prove it. Then you want to compute unencrypted data to keep things private, because confidentiality is needed. That's why you have FHEVM. But of course, the holy grail would be to combine all of these properties in something that would be FHE zkFHEVM, zkfhEVM. I don't know. Maybe a better word would be needed at some point, because it's becoming barbaric. But that's, of course, the holy grail, but it's not accessible and feasible right now for scalability and computation time issue. So it will take like ages to do a simple computation like this, but that's something we are aiming towards. So I cannot say when it will be available. For sure, ASICs, so custom hardware, will be needed. Then in our case, they are coming in 2025, but I think it won't be enough. You also need some improvement on the lots of on the whole, all along the stacks, on the software part, hardware part, everywhere to make it. But who knows? Even Vitalik thought that ZK acceleration would take like dozens, 10 years. It only took 4 years for the L2 ecosystems to implement. So might go faster than expected.
Yeah, and that's something I think I've realised from the discussions that I've had, and it's easy to forget that obviously we are in, very much in the infancy of the research in ZK, and certainly FHE as well. But the amount of research that's going into it from, Ethereum Foundation and other bodies, the grants, the PhD education, and the courses and the research and the papers and the literature. There's so much that's being piled into this, because I guess it is such a massive growth area that, I think it's going to exponentially, grow in terms of use cases. But it's, certainly where cryptography in general is gonna take us to. And I know obviously you're on the Web3 and blockchain side of things, but certainly, do you see massive growth potential for I guess a combined ZK and FHE use cases once again further afield outside, obviously, once the chip shortage or delay in those is sorted on the hardware side?
Yeah. I think beyond blockchain, this technology will be used everywhere. And one case we have is, LLMs, even outside the blockchain, in the AI world. Using LLMs, you're giving lots of private information about you, exactly as you were giving to Google. And we think that's this additional layer of encryption where you could send encrypted requests to LLM, for example, and they could compute the results without seeing your input, is something we'll need it. Whether it comes by the law, with a law like a GDPR or similars, or if it comes from the developer themselves implementing this into the product. But what we believe at Zama is people shouldn't care about privacy. Developers should. That's why we are optimizing everything for developer experience. We try to make our Rust library the best, so that they can easily implement them into the product.
Yeah. Also, I think, from my side of things, in its simplest format, I guess, as there is more and more data made available so easily, like you mentioned, with the use of AI and everything else in between, that I guess there is I wouldn't say fear, but there's a element of distrust that might be used in an untoward fashion, and therefore anything that can be used to protect what you need to be protected is certainly going to be, well, very much beneficial, I think, just for the average Joe like me. Awesome. And I guess just to round things off then, you're in a fortunate position, I guess, where you sort of oversee the technology side of things and the tech, but also, across, sales and partnerships. But what advice would you give to someone who's interested in FHE and cryptography and wants to get in the space? That's a question I'm keen to ask, because it's once again I said it's a massively growing area, but it's still pretty niche right now. So people are desperate to make a move and find a way to get involved. So any advice you'd give?
Yeah, absolutely. So as always, for like early technologies, it's always easier if you're a developer or a technical person, easier to find a place. And so what I would advise is first to have a look on our bounty program. We have bounty program where if you build application using FHE, like games or lots of different things, chess, we pay you for this. You can submit your application. Then we have different communities. We are running FHE.org, which is it's not essentially linked to Zama, but it's in FHE in general. You could learn a lot from this community. There is a Discord and there is an annual meeting about FHE. Then, you can follow. We are present to every blockchain conferences. Always organizing side events. So just talking to us is a good way of finding a place. And that's it. Yeah.
Brilliant. And I think you touched upon it there in terms of the community, I guess, from the zero knowledge side of things. I'm sure it's very much the same. It's still very niche. It's still community driven. There are so many different talks. You might have to travel a little bit, but yeah, just going to those, immersing yourself, meeting people, building open source stuff, contributing to the bounty like you mentioned, and just trying to immerse yourself into the technology as much as possible, I think is where you're going to have the most success. Awesome. Is there anything else you wanted to add? I think I've certainly covered loads and plenty that I wanted to touch upon, but anything you wanted to round off with?
Yeah, no, just maybe adding that maybe an easiest way to get into FHE is just write to me. So if you're listening to this video and are interested in some ways of anything FHE related, just write to me on LinkedIn, Telegram, or any other platform on Twitter, on X, sorry. And I'd be happy to have a look on what you want to build and why you're interested.
Brilliant. So yeah, if you're happy to, I'll share your details on our website and in the comments section, and those links and bits and pieces you mentioned, I'll share them too. And yeah, anything that Jason can do, I'll probably go to Jason instead of me. I'm not sure I'll be able to help much, but anything Jason or Zama can do to help out, that would be great. I'm sure, as he said, he's willing to do so. So yeah, well, a massive thanks, Jason. Once again, I've learned loads, and yeah, I feel like I'm getting my head around FHE and the differences and the different use cases compared to ZK, and it's given a nice overarching picture of cryptography as well. So yeah, thank you very much for your time. Massively appreciated, and we'll speak soon.
Thank you very much for having me. Bye.
Cheers. Bye.